Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4. Now we are present about this ambassador mission. Objective about this project is the project aims to enhance maintenance and repair process for this ambassador, simplifying engineering tasks through systematic identification and resolution. Problem statement. Engineer deal with discuss problem which are maintaining and repairing equipment which leads to inefficiency and extend downtime. First, complexity of issue, effect of downtime, and use of location. Next problem statement. This project is problem identification is time-consuming and the lack of standardized approach high-quality issue resolution. First, time-consuming analysis, inconsistent practice, delay solution. Signification of project. Number one, revolutionizing equipment maintenance and repair practice. Strategic overhaul, editing to capacity. Number two, powering engineer which structure problem solving approach. Became decision making. Consistent practice. Number three, alignment with a broader organization goal. Increase productivity, cost effectiveness, uh, and strategic vision.
Scope of work. For bearing, we focus on determine how long ball bearing may be rated in order to improve predictive maintenance and replacement scheduling. So our research for engineer that we found analyze the current ball bearing condition and requirement, use method and formula that commonly used in the industry to find the ball bearing rated life, examine possible upgrade or substitution in light of the determined rating life, provide standardized method for evaluating and documenting the status of ball bearing. So for belt, we focus on how to measure belt dimension to streamline procurement and inventory management procedure. So we analyze the existing belt inventory and specification, including all dimension. Provide a way or formula for figuring out how much space each kind of belt take up. To determine the current belt inventory volume, use the suggested methodology. Examine options for standardizing belt dimension in order to make volume calculation easier for later. So for methodology, we use flowchart to show our progress. So we start and then receive and discuss assignment with our team member and then determine objective and two component that we use for our project and then contact person in charge and decide on what date we need to site visit. If the PIC not accepted, select another date. If PIC accepted the date, we continue with attend the site visit. At site visit, we collect data and then after collect data, we analyze it and then we write a report and using a Excel for calculation and then presentation, submit report and that's all. So for procedure, one, perform on site site visit inspection to learn about the state of the machinery and upkeep procedure. Second, relevant data such as equipment spec and maintenance record from the past should be methodically acquired. Third, develop and implemented industry standard formula to determine bed volume and ball bearing rated life. Using same example for bed and bearing, this calculation demonstrate how to use the formula. And last, use a spreadsheet software which is we use Excel to develop intuitive tools for effective data and organization calculation and for visualization. I will explain about formula that we are using to create our parameter. So we have 7 type of formula that we use to create flat belt dimension. So the first formula is power is equal to torque omega, and the second one is omega is equal to 2 pi n over 60, and the symbol n is referring to rotational speed in unit RPM. And the next formula we are using is torque is equal to tight side minus slack side times this radius at small pulley. And in the next formula, basically we do the research to get this formula, so we get it from our references. So the formula is diameter at big pulley divided to diameter small pulley is equal to tight side over slack side. So basically this formula called ratio tension, and the next formula that we use is phi is equal to pi minus 2 alpha. And the next formula we use axial stress formula is equal to maximum tension, which is the tight side is equal to area of the belt. And the last formula is the length of the belt, which is 2 um, 2 times center distance between two pulley plus pi times with radius at big pulley plus at radius at small pulley plus 1 over center between two pulley, and then times with radius at big pulley minus radius at the small pulley. And the operation of the minus is we need to uh, square we need to power square with it. And then we go to the another slide, which is the sample calculation that I made for the flat belt. So basically basically our objective to create this sample calculation, basically we want to get the area of the belt and the length of the belt. So basically the data collection that we have for from site visit, so basically we have the power motor and the rotational speed, diameter big pulley and diameter small pulley, and also the value of the center distance between two pulley. So and then we make a research on type of belt material, which is the stress. So we get from the internet, which is they use 2 type of belt, which is aluminum carbide and silicon carbide. And the value of axial stress for aluminum carbide is 416 megapascal, and the next axial stress for silicon carbide is 588 megapascal. And then we just put the value on the formula, uh, and then we get the value for the omega is 205.25 radian per second. And then we have torque is equal to 53.59 newton meter torque. And then we have ratio tension is about 1.01 ratio tension. And then we just substitute the value, and until we get the value of the F2 is equal to 133,965.0174 Newton. And then we get and then we put the value of the F2 into the ratio tension, and then we get the value of the tight side, which is 135,493.34 Newton. And then we calculate the value of the alpha, and then we just put the value of the radius big pulley minus radius small pulley divided by center distance between two pulley. And then we get the value of alpha is 0.000687 radian. And then we put the value of the alpha into this formula. So then we can get the value of the phi, which is 3.140 radian. And then we can get the area of belt using this formula, which is axial stress is equal to F1 over area. And then we get the area for the belt is 0.003 meter per second squared. And then we just put value for C, R2 and R1, and then to get the value of the length of belt, which is 1.3891 millimeter. So then we go to the formula that we are using for ball bearing. So basically for ball bearing, we use only 4 formula, which is the first one is equivalent radial load.
So we use shock loading vector, which is the formula is P is equal to KSVFR, and the second formula is rating life in revolution, which is C is equal to P power of A, which is the C is referring to basic dynamic load rating, and P is equal to equivalent radial load, and then the A is factor. Factor is the factor. If factor is value 3 for ball bearing, and then the last formula that we use is median life is equal to 5 time with L10. So this is our sample calculation for ball bearing. So basically from the previous calculation, so we use F1 plus F2 as a radial force, and then we calculate the rating life about rating life of bearing. So basically, we just put all this value into the formula, and then we can get the equivalent shock loading is equal to 269,408.45 Newton, and then we put the value of P into the second formula, and then we can get the rating life in revolution, which is 0.091 revolution. And then number three, we just add the rotational speed that we get from the sample calculation before of that dimension. So we just put the value of n to this formula, and then we can get the rating life in hours, which is 0.7703, and then we can get the value of median life, which is 5 times with L10 in revolution, and then you can get the value is 3.189 hours.
So next I will explain for the result from the Excel. Firstly, we choose two parameter, which is flat belt and ball bearing. For the flat belt, this is the parameter, which is power, diameter driven, center distance pulley, rotational speed, and backstress. This is parameter that we can choose either to change the value to get a different result of area of belt and length of belt. So this is our formula that we use. In the result of ratio tension, type side tension, slack side tension, torque angle, and angle of contact. This formula that we use in this formula to get the value of area of belt and of belt. So when we calculate the formula from the, for example, tight side tension and slack side tension, we use this formula and we get the result of area of belt and length of belt. So next, the parameter of ball bearing. So this is the parameter: rotational factor, shock factor, radial force, ball diameter, basic loading rating for angular contact, ball diameter, basic loading rating for deep groove. We separate the deep groove and angular contact for easier for the user to choose. For example, we use the VLOOKUP method on this parameter because, for example, the rotational factor has two rotational factor, inner ring and outer ring. By using the VLOOKUP method, we can only change the name of the rotational factor. If the user want to choose the inner ring, just click on the inner ring and the value will auto install in the Excel one. And if the user want to use the outer ring, just change the name of the rotational factor and the value will auto update to 1.2. So that's how the VLOOKUP method operation. So after we choose the rotational factor, shock factor, and we get the basic load rating. This basic load rating, we have to decide for ourselves. We have to insert the value by choose the bore diameter. If we bore diameter, for example, 0.095, we can choose the value in the table, and the value of the basic load rating will auto update. So in the basic load rating decided, we have to insert the value. So the result, we can get the rating life in revolution, rating life in hours, and median life.
Discussion. Discussion. Firstly, determine the rated life of deep groove ball bearing is a critical aspect to optimize equipment maintenance. These measurements serve a basis for making strategy decisions, significantly impacting maintenance procedure. The next discussion is the approach reduce risk and align with the main goal of reducing downtime and increasing equipment reliability. This marks an important step towards data-driven and responsive equipment maintenance procedure. This dimension creates a clearly important framework for refining and optimizing strategy related to the various tasks. Standard dimensions serve a reference point for preventive maintenance, ensuring timely replacement or change based on a clear timetable rather than a reactive response to damage. And lastly, the continuous adaptation and integration of this dimension into the maintenance process position for long-term progress in maintenance procedure. So lastly, for the conclusion, this project is poised to revolutionize equipment maintenance and repair practice by offering structured problem-solving approach that speed up decision making for engineers, such as the Excel that we create. It will speed up our decision making by changing the value, so we don't have to calculate from the start using the same value. Next, seamlessly aligned with organizational goals, this initiative promises increased productivity, improved cost effectiveness, and a strategic vision of operational excellence. Beyond procedural improvement, the project includes the integration of advanced technology, a comprehensive training program, and the establishment of collaborative engineering community focused on sharing expertise in ball bearing rating life and depth dimension. So lastly, the expected outcome for the overall organizational performance, equipment reliability, and maintenance efficiency is a positive and lasting impact. That's all from us. Thank you.